Hey there. So, when you picture the solar system, you probably imagine this one big, happy family of planets just circling the sun, right? Well, the reality is a little different. It's actually more like a city with two totally distinct, very separate neighborhoods. Today, we're going to explore this cosmic divide. So, yeah, that brings us to the big question, doesn't it? We've got two completely different kinds of planets in the exact same system. What in the cosmos made them that way? Let's dive in. The first thing to really get your head around is that our solar system is a system of opposites. You've got these small, solid worlds all huddled up close to the sun. And then, way out there, you have these colossal, swirling giants lurking in the outer darkness. We're talking two completely different blueprints for how to build a planet. And get this, there's an actual physical border separating these two neighborhoods, the asteroid belt. It's this massive ring of rock and debris that acts as a pretty clear dividing line between the inner and outer worlds. And wow, this table really just lays it all out, doesn't it? I mean, look at the contrast. From what they're made of and how big they are to their density and whether or not they have rings, these two groups of planets could not be more different. So let's break down these two planetary flavors, starting with the inner worlds. All right, let's start on our side of the tracks, inside the asteroid belt. Welcome to the suburbs of the inner solar system, home to the small, rocky terrestrial planets. So, terrestrial, what does that even mean? Well, it comes from terra, which is just the Latin word for Earth. It basically tells us these planets are like solid, rocky balls. They have a hard surface you could actually, in theory, stand on. So the inner planets, we're talking Mercury, Venus, Earth, and Mars, they all share some key family traits. They're all pretty small, super dense, and compact. They have very few moons, if they have any at all, and they tend to spin really slowly on their axes. Okay, now let's cross that asteroid belt into a totally different part of town. This is where things get big, gassy, and, well, kind of strange. We're talking about the realm of the Jovian giants. The term Jovian just means Jupiter-like. And unlike the terrestrial worlds, these planets have no solid surface at all. They're just these massive, swirling balls of gas and ice. There's literally no ground to speak of. And their family traits? The polar opposite of the inner planets. They are absolutely enormous, but have super low density, almost like cosmic foam. They have these thick, crushing atmospheres, dozens, sometimes hundreds of moons. I mean, Saturn has at least 146, and they all have ring systems. Oh, and they spin incredibly fast. To really wrap your head around the size difference we're talking about, we need to look at the king. Jupiter isn't just the biggest of the outer planets. It is the biggest planet in our solar system, period. It is just mind-bogglingly huge. Okay, to put it into perspective, you could fit our entire planet, Earth, inside of Jupiter. Get this, over 1,300 times. That one fact right there just perfectly captures the staggering difference in scale between the two neighborhoods of our solar system. Okay, so we've established what the differences are. They're big, they're small, they're rocky, they're gassy, but the real question is why? Why did our solar system split into these two distinct neighborhoods? Well, the answer lies in its fiery birth. It all boils down to one simple thing, really: temperature. See, when the sun first lit up, it was incredibly hot. So close to the sun, only heavy stuff like rock and metal could handle the heat and condense into solids. But further out, past a point that scientists call the frost line, it was cold enough for lighter materials like ice and gas to freeze into solids too. And there was just way more of that icy, gassy stuff available, which is the key to why those planets grew so enormous. The planets just formed from whatever building materials were available in their zone. So it's not a coincidence at all. It's a direct consequence of creation. This quote sums it up perfectly. The main difference in their composition, size, and location is a direct result of how the solar system formed. Location dictated the ingredients, and the ingredients dictated the final planet. Simple as that. All right, now that we know all this, let's bring the focus back home. Because even among its rocky siblings, Earth is, well, it's something special. So how did we get so lucky? Well, there are a few key reasons. First, you've probably heard of this one, our Goldilocks location. We're not too hot, not too cold, just right for liquid water. Second, our amazing atmosphere acts as a protective shield. And third, and this is a reason you might not think about, Our giant neighbor Jupiter acts like a cosmic vacuum cleaner, using its immense gravity to protect us from a ton of incoming asteroids and comets.
And this is exactly why our neighbors didn't quite make the cut. Venus became this runaway greenhouse inferno, literally hot enough to melt lead. Mercury is just an airless rock with brutal temperature swings. And Mars? Well, Mars was just too small and cold. It couldn't hold on to its atmosphere or its protective magnetic field.
So that kind of brings us to our final thought. We live in a solar system of two starkly different neighborhoods, and we just happen to live on this very special, just right world in one of them. Which really leaves us with this question. As we look out at the billions of other solar systems out there, how many more are like ours? How rare or how common is a planet like Earth?